Hey, how's it going, guys? All right, guys. How's it going? We got Abby, Bernice, Elizabeth, Elena, Abby again, Dom, Caitlin, Lucy, Kristen, Abby, Christina, Caitlin. Are you serious, Lucy? Hey, Maddie. So, 201. Seeing if anybody drops in. Don't see Josiah. Sebastian told me that he's unable to chat. All right. So let's just go ahead and get started. Looking at lesson 5.3 homework. Any questions on 5.3 homework? So number 9, Abby says 9. All right. So looking at number 9, let me jump in here. Look at number 9. 9, 11. Okay, so look at number 9 first. So this one right here, plus 6, makes me go left 6. I'm going left 6. And then really this minus 5, it really could be over here is another way to think about that. So you could think about going down 5. So left 6, I don't know if I said that right to start with, but left 6 and down 5. Left 6 and down 5. That should be our point there. And I've really taken care of the minus 5. I've taken care of this right here. Now, typically, with a radical x, we would go right 1, and up 1, right 4, and up 2, right 9, and up 3. But now what we need to do is from this point right here, that y coordinate over here from the point that we start at just needs to be multiplied by 2/3. So go right 1 and up 1 times 2/3 is 2/3. So not quite 1. Right 1 up about 2/3. Go right 4, 1, 2, 3, 4, and up 4/3, which is just a little bit past 1. Go right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and go up 2, 1, 2. So it should take on this shape right here. You cool with that, Abby? Give me yes, no, smiley face. I don't care. Cool beans. Okay. Are you good, Elena, with 11? I see you said never mind. I understand 11 now. Are you for sure you're good? Just give me yes, no. Go ahead and work it, whatever. Any other questions on 5.3 homework? Any other questions? 5.3 homework. We feel pretty good about it. Let me know. Smiley face. I'm good. Whatever it is. Thank you, Kristen. Thank you, Bernice. Thank you, Christina, Caitlin, Kelsey, Abby. Thank you, Elizabeth, Dom, Elena, Lucy. Very good. All right. So if that's the case, let's put this 5.3 homework into your notebook, or right behind 5.3 notes, or wherever you go with it. And let's move right along to 5.4 notes. Smiley face or something when you're ready. When you're ready to go, you got it out and you're ready to go. I don't care, Abby. You can keep it, throw it away, recycle it. Elaine's ready. Don's ready. Christina's ready. Bernice, Caitlin, Abby, Lucy, Kelsey, Kristen, Elizabeth. Okay. Now, 5.4 notes is solving radical equations. Now, Elaine is going to go crazy, but well, didn't we already do this in 5.1? And we did get a little bit of a taste of it in 5.1 of like squaring both sides or raising both sides to like the fifth power or whatever it may have been. But this may just lead us to a few different things. But all in all, know that we may see something a little bit different going through here. So that's why I've only put 6 problems on here. So this notes section, this is probably going to be pretty straightforward. Okay. And pretty simple in it all. I hate to hear that you guys are spending literally hours upon hours on everything. Sounds like you're doing a little bit more now than what you normally even do while we're in session or in school. So I hate to hear that, and I apologize if I'm part of that reason. So I guess it is what it is. So jumping in to number 1. I have a square root on both sides. So I need to get the square root off. I need to square both sides. So I'm going to square the left side. I'm going to square the right side. When that happens, I get 1 minus n equals 3n plus 21. Why does the square root and the square automatically cancel? Someone type that into the chat box. Why does the square root and the square cancel? Because they are what? Opposites. Listen to you guys sounding elementary in here today. Converse conjugates. Converse conjugates. Thank you, Elena. Inverse operations. I don't know what Lucy and Christina. Converse conjugates. There's a thing called complex conjugates. That's where it's the sign in the middle is different. But hey, there we go. Inverse operations. So now we just then solve this equation. So I'm going to add n to both sides. Get 1 equals 4n plus 21. Subtract 21 from both sides. Cancels. And I get 1 minus 21 is negative 20 equals 4n. Divide both sides by 4. And I get n is equal to negative 5. I'm not going to box that in just yet, because I need to check for up here. Check for extraneous solutions. So we got to check for the extraneous solutions, meaning that when you derive the formula, it gives you this, or the equation, it gives you this, but it may not actually solve it. So plug that back in. Radical 1 minus negative 5 is equal to radical 3 times negative 5 plus 21. The minus goes to a plus, and that's radical 6 is equal to radical negative 15 plus 21, which would be radical 6 equals radical 6. So therefore, we know that that works. Questions on number 1? Correct, Abby. If it's extraneous, it's a solution, but it would not work once you plug it back in. So this is the answer. Okay. Moving over here to number 2. 28. All right. So Maddie asked, what do you mean it wouldn't work? So basically, Maddie, if something's extraneous, you get it as a solution, but when you plug it back in to the variable, you would get something like radical 6 and equal to like radical 8. That's not equal, so therefore it would be an extraneous solution. Most of the time, your extraneous solution is going to come when you have 2 answers. Okay. All right, number 2. Talking to you, Kelsey, you're with us today. Kelsey, what would be the first thing I would do here with number 2? Talking to Kelsey. Type it into the chat box. Okay, Kelsey said square both sides. So we can avoid some stuff. Before we square both sides, let's divide both sides by 7, Kelsey. And that'll kind of that'll kind of make it a little bit easier to solve this. So then if I divide both sides by 7, that cancels and cancels. And then that would give me 4 equals radical negative 4 minus 4m. Because if I had to square 28, that'd be a large number. Then if I have to square the 7 along with that, then I'd have to distribute. So always divide. Try to isolate the square root is what we could say. Always try to isolate the square root. Okay. From there, what would I do, Kristen? Kristen Phelps. What would I do from there? Yeah, square both sides. Very good. Square, square. What's my next line, Abby? Abby, throw out that next line. The equal sign is the same as plus, which is 2 buttons to the right of 0 on your keyboard. Thank you, Abby. So Abby said 16 is equal to no, you're okay. Yeah, so again, the square and the square root cancel. No worries. So then you just drop this down. I'm glad you did it because most likely it will probably never happen again now. Okay. Then from there, add 4 to both sides. Cancels. I got 20 is equal to negative 4m. Divide both sides by negative 4, and we find m to be negative 5 again. Let's plug that in, though, we need to make sure it's not extraneous. 28 is equal to 7 times negative 4 minus 4 times negative 5. So that's 28 is equal to 7 radical negative 4, and that's going to be plus 20. 28 is equal to 7 times radical 16. 28 is equal to 7 times 4. 28 is equal to 28. So therefore, negative 5 is our answer. Thumbs up, smiley face if we're good on number 2. Thank you, Maddie. Thank you, Elizabeth, Elena, Bernice, Lucy, Dom, Kristen. Good, Kelsey. Good, Christina. Good, Caitlin. Okay, jumping down to number 3. Look at number 3. How about it, Christina? This looks a little bit different, but what would you do here first? A couple different options you can go about this one. What would you do first, Christina? Just type. You can type it in. Okay, make the index 2. So if you all remember, your denominator is your index. So basically, what Christina is saying, that I think she's saying, is take it from exponential form to radical form. So it looked like this: the square root of 13 minus p to the first power, which we don't have to put, equals the square root of p minus 3. Okay? And then let's just square. I think it's somebody saying, I think Elena down there screaming, let's square both sides. And Bernice, what would be my next line? If I square both sides, what would be my next line? Type it out. Good. 13 minus p equals p minus 3. Okay. Now, going back up to the top, if I said there was another way to do that, can anybody, what is the other way I could do this? From the start there, does anybody see what I could do there to, what could I do right there in order to Yeah, square it. Very good. So if I square from here and square this side, anybody remember what that is called right there? A power to a power? So basically you multiply that. 1/2 times 2, and half of 2 is 1, so it just would go to the first power. So it's like these just cancel. These would cancel out because 2 times 1 is 2. 2 over 2 is 1. So they'd cancel out and give us this line right here. From there, we add p to both sides. Cancels there. And I have 13 is equal to 2p minus 3. I then add 3 to both sides and get 16 is equal to 2p. And then I see that p is equal to 8. All right, jumping over here to number 4. 1 equals -6 plus the quantity of v minus 4 raised to the 1/2. Oh, yeah, good call. Check for extraneous. So 13 minus 8 to the 1/2 is equal to 8 minus 3 to the 1/2. That would be 5 to the 1/2 is equal to 5 to the 1/2. So we're good there. Good call, Abby. Elena, 13 minus 8 is 5. Okay, cool. All right. So looking at this next one. So I just said always try to treat radicals and these v minus 4 to the 1/2, which is really a radical. Treat it like a variable. So get everything else away from it. So let's add this 6 to both sides. And we get 7 is equal to v minus 4 to the 1/2 power. Okay. How about Elizabeth? What would I do from here? Square both sides. Very good. So I'm going to square both sides. And then that would take me to 49 is equal to v minus 4. That cancels. Or they multiply to equal 2 over 2, which is just 1. I add 4 to both sides. I get v is equal to 53. Okay. All right, check for extraneous. 1 equals -6 plus 53 minus 4 to the 1/2 power. So that's 1 is equal to negative 6 plus 53 minus 4 would be 49 to the 1/2 power. 49 to the 1/2 power is 7. And negative 6 plus 7 is 1. So that would be my answer here. Thumbs up, smiley face. You see what's happening? Muy bien. Okay, jumping to number 5. The square root is by itself. If the number is extraneous, would you write no solution? Correct. That is correct, Caitlin. If 53 did not work, then it wouldn't have any solution at all. Because technically right now it just has one solution, but if that solution did not work, it would be no solution. Okay, coming back up here, the square root is by itself. So we have to square this. And what I do to one side, I must do to the other. So that would take me to m squared equals negative 40 plus 13m. And this is really the part where we didn't see in lesson 5.1. We saw some of this basic stuff, but this is getting out of this part. This is where we really didn't quite see that much. So m squared equals negative 40 plus 13m. And then obviously the square root and the square cancel. And then it gives me this. So then I need to set this up in order to solve it. This is a quadratic equation. So I have to solve by saying m squared minus 13m plus 40 is equal to 0. Anytime I see that square, I need to be thinking, and another variable, I need to be thinking quadratic equation, which is factoring, completing the square, or quadratic formula. So leading coefficient is 1. C is 40. 1 times 40 is 40. Great question. Why did I switch these? Why did I switch the 40 over there and the 13 over there? I just need it in that form, Abby, of ax squared plus bx plus c equals 0 in order to factor it. So I need it in this form, so I move those over. Because if I would have subtracted the m squared, then I would have to divide a negative out, which I could have done. But remember, I can't have a leading coefficient that's negative, so I just move those over. You cool with that, Abby? Okay. So now talking to you, Maddie Burris, what will multiply be 40, but add to be negative 13? Good, Maddie. Negative 8 and negative 5. So I would then write this. Since my leading coefficient is 1, I can just write the factors out. M minus 8 and m minus 5 equals 0. Christina, what's that property called? Type it out in the chat box. That says if A times B is equal to 0, then A is equal to 0 and B is equal to 0. What is that, Christina? Zero product property. She is a vocabulary queen. I almost said diva, but they tell me you're not a diva. What's in your profile picture today? Is that you when you were like 2, Christina? Are you 2 together today? All right. So we have M equals 8. Yeah, like are you guys in the same room? And M equals 5. Okay. So now let's check for extraneous solutions. 8 equals radical negative 40 plus 13 times 8. So that's 8 is equal to radical negative 40. And then I want to say that's 104. I'm going to assume I'm correct. Then 8 is equal to radical 64. Therefore, 8 equals 8. Then let's check 5. 5 is equal to radical negative 40 plus 13 times 5. So that's 5 is equal to negative 40. And that's, I'm going to say that would be, what is that? Negative 65 or positive 65, excuse me. Which is 5 is equal to radical 25 and 5 equals 5. So 2 solutions here. I have M is 8 and 5. Yeah, right like that. Okay. Last one, 6. So we have M equals 4 plus M equals 4 M equals 4 plus radical 2M minus 5. So as I said, let's try to isolate the square root if we can. So that would take us to M minus 4, when I subtract 4 from both sides, is equal to radical 2M minus 5. Okay. So then from there, in order for us to get that square root off, we are going to have to square both sides. Square this, square that. What am I going to have to use on the left side? What is that called? That acronym. Good, Elizabeth. FOIL. M minus 4 is equal to 2m minus 5. So let's full it up. And we go first. M squared, or excuse me, m times m is m squared. Outside, m times negative 4 is negative 4m. Inside would be negative 4m. And last would be positive 16. And that's equal to 2m minus 5. So we clean this left side up. Look at Elena going crazy. Minus 8m plus 16 equals 2m minus 5. I got negative 8m from negative 4, negative 4. I then subtract 2m from both sides and add 5 to both sides. Those cancel on the right, leading me to m squared minus 10m plus 21 equals 0. How about it, Caitlin? What will multiply to give me 21 but add to give me negative 10? Caitlin Gibson. Negative 7, negative 3. Caitlin, is your mom watching? M minus 7 times m minus 3. So from there, we know m minus 7 is equal to 0. M minus 3 is equal to 0. M is 7 and m is 3. Okay. So now let's check for extraneous solutions. So let's try 7. I don't have much space, but I can figure it out. 7 is equal to 4 plus radical 2 times 7 minus 5. 7 equals 4 plus radical 14 minus 5. Seven equals 4 plus radical 9. Radical 9 is 3. 7 equals 7. So 7's good. Let's try 3. 3 equals 4 plus, I'm just going to say 6 minus 5 because 2 times 3 is 3. I don't really have a lot of room here. That's 3 equals 4 plus radical 1, which is 4 plus 1 is equal to 5. That does not equal. So my only answer, I don't have to say that's extraneous. I just have to say my answer is m equals 7. I don't have to say m equals 3 is extraneous. I just got to say, my answer is m equals 7. Trust me, on a test, if you got something like this, it would say 7 and 3. Try to throw you off, but always check for extraneous solutions. All right. Hey, real quick, if you don't mind, before we get off here, go to your homework. I think so, Maddie. I'll look on the schedule once we get this. Once we're finished. So looking at number 9, we didn't see one of these. All right, give me a smiley face if you got the homework out. You see what I'm talking about. Thank you, Caitlin. Thank you, Lena. Thank you, Abby, Bernice, Maddie, Kelsey, Lucy, Elizabeth. All right, so you kind of know what I'm talking about here. So in this case, notice we have square roots on both sides, but we also have a 2 here. All right, we also have that 2. So what you're going to have to do, okay, is you're going to want to square both sides, okay, but you're just going to have to FOIL this left side. Sorry, I didn't have any like that on the notes. It just kind of happened that way. So it should look something like this. 2 plus radical -1 minus r. And I would write it out like this just so you can make sure you multiply correct. -1 minus r is equal to 1 minus 3r. Thumbs up on that. Are we all seeing that? Cool. Now you actually have to FOIL this. So you got to say first, 2 times 2 is 4. And then go outside. First, outside. That would be plus 2 radical. That's correct, Maddie. -1 minus r. You go inside. That's plus 2 radical -1 minus r. And then if we notice what Maddie said here in the chat, she said when you multiply these two, remember when we had like radical 2 times radical 2? The answer is just 2 because 2 times 2 is 4. Same thing here. When you're multiplying this radical, when you're multiplying radicals that are the same thing underneath, it's just going to be that. So it should just be -1 minus r. And then equals 1 minus 3r. And if you can remember what I told you about radicals, I always said treat radicals like they are what? Someone type that in. Treat radicals like they are Beautiful, Kelsey. Yes, yes, yes. Man, you guys got a good math teacher. So 4 plus, so treat this like they're variables, and then I can say 4 radical negative 1 minus r, and then minus 1 minus r equals 1 minus 3r. Then I can start dealing with this over here. So I can say 4 and negative 1 would be 3. 3 plus 4 radical negative 1 minus r. And don't forget about this minus r. Minus r equals 1 minus 3r. Then I'm going to subtract 3 from both sides and add this r to both sides. I'm trying to get like terms together. So then that would leave me with 4 radical negative 1 minus r. Dude, I was about to go crazy with that. Look at that. That's huge. I was about to go crazy. So equals 1 minus 3 is negative 2, and negative 3r plus r would be negative 2r. Okay. From there, I think I have some options here in what I can do. Anybody want to throw out their opinion, what you would do from here? Add 2, divide by 4, divide by 4. Okay. So let's divide by 4. That seems the majority of the people that answered. Divide both sides by 4. Cancels on that side, leaving me radical negative 1 minus r. We're not afraid of fractions, are we? All of this cancels inside here. So 2 will go into itself once. It'll go into that once, and it'll go into that 2 times. So I have negative 1 minus r over 2. I would square both sides here. Yeah, that's what I would. That's where I would go next. Square both sides. That would leave me at negative 1 minus r is equal to. Now, don't get this messed up. This square has to go to the top and the bottom. So it has to look like this. Negative 1 minus r squared over 2 squared. So this is getting pretty nasty. Negative 1 minus, oh, sorry, my bad. Thanks, Christine. Okay. So again, I canceled those, squared that. When you add this, you have to put it to the numerator and the denominator here. You say, wouldn't that be a positive 1? Oh, okay. All right. So negative 1 minus r, and I'm gonna write this out. Negative 1 minus r times negative 1 minus r all over 4. Okay. So then from there, let's figure out what this is. So it'd be negative 1 minus r equals, go first, 1, go outside, plus r, inside, plus r, last, plus r squared. And all of that's over 4. From here, I'm going to multiply both sides times 4 to take care of the fraction. So that cancels with that. And then coming over here, I have, if I just go ahead and distribute that in there, I have negative 4 minus 4r is equal to 1 plus 2r plus r squared. I'm just going to move everything to this side. So I'm going to add 4 to both sides, and I'm going to add 4r to both sides. Cancels, cancels. 0 is equal to 5 plus 6r plus r squared. I'm going to write it in ax squared plus bx plus c form. R squared plus 6r plus 5. What will multiply to be 5, add to be 6? Should be 5 and 1. 0 is equal to r plus 5. R plus 1. And then, therefore, we know that that would then be negative 5 and negative 1. Check for extraneous, negative 5 and negative 1. So that's 2 plus radical negative 1 minus negative 5. That's 2 plus radical negative 1 plus 5, which is 4. So that's going to be 4 there. Equals radical 1 minus 1 minus 3 times negative 5 would be positive 15, which would be radical 16, which is 4. So negative 5 works. Negative 5 is, my goodness, negative 5 is good. Now check negative 1. 2 plus radical -1, that's going to be +1, is equal to 1 minus 3 times -1. So that's just going to be 2 there is equal to 1 plus 3 would be radical 4, which is 2. So both of those values work. That's no lightweight problem. That's a lot of algebra there. A lot of room for mistake. A lot of room for mistake, but that is your answer there. I don't know how far up you want me to go, Christina. All right. Yeah. So that's what I was actually about to tell you. If you're looking at 10, and guys, keep in mind, you can always go back and rewatch it. But if I'm looking at number 10, notice over here we had a constant with a square root is equal to a square root. Over here we have a square root minus a square root equals 2. Yeah, no problem, Lucy. So you could add one of these. I think you have two options here. You can square this side and square that side. And then you literally have this problem right here, 4r minus 3 minus radical 4 minus r times radical 4r minus 3 minus radical 4 minus r is all equal to 4. And then you would have to FOIL that. But here is where your issue would run into doing that. It works here, but when you went to go outside, that's when it would get real nasty. And that would still be a square root there. So you would have to say 4r minus 3 times 4 minus r. So then you're going to have a binomial times a binomial under a square root. And that's a nightmare. So I wouldn't go that option unless you're just like, I know you have a bunch of free time, but again, that's even with all the free time we have, you don't want that drama. So what I would do is I would add I would set the problem up like this: 4r minus 3 equals 2 plus radical 4 minus r, and then I would solve it just like we did this last one, like that. Does that make sense, Abby? So I wouldn't even probably think about doing that because it's going to lead to a nightmare. Just go ahead and add that radical 4r over and then square both sides, work it just like we did this. Hey guys, here is what I'm looking at for next week in terms of live classes. These are all live sessions. So 3 live sessions next week: Monday, Wednesday, Friday. Monday is at 2 like we've been doing, but due to my scheduling of my other classes, Wednesday's going to have to be at 11 and Friday at 11. I will send this to you in a schedule, so don't feel like you got to write it down, and go off what I send you, because if something crazy happens and I have to change something up or something like that, go off what I send you. But this is tentative right now. I know some of you are working. You need to kind of know, hey, when do I have a class? When do I not have a class? Whatever. So that's that. And I know some of you guys are asking about it. Any other questions of me? All right, give me thumbs up, smiley face if you're good. Don't have any more questions. If you do, feel free to hang out a little bit. I'm going to be. I'll stay on for a few minutes. Good day to all of you. Good day. You may be dismissed unless you have any other questions you want to ask me. Good day, Maddie. Good day, Bernice. Good day, Elizabeth Woods. Good day, Miss Gibson. I think she's outside, Abby. You need to talk to her. Let me go get her. Okay. What is it? What is it, boys? Good day. Deuces has an E in it, by the way, Abby. Okay, no more questions. I'm going to end the stream.